Designing data-intensive applications. Designing data-intensive application. The big ideas behind reliable, scalable, and maintainable systems. Designing data-intensive applications. The big idea behind reliable, scalable, and maintainable system by Marty Kleppman. Copyright 2017, Marty Kleppman. All rights reserved. Printed in Canada, published by O'Reilly Media, Inc. Technology is a powerful force in our society. Data, software, and communication can be used for bad, to entrench unfair power structures, to undermine human rights, and to protect vested interests. But they can also be used for good, to make underrepresented people's voices heard, to create opportunities for everyone, and to avert disasters. This book is dedicated to everyone working toward the good. Computing is a pop culture. Pop culture holds a disdain for history. Pop culture is all about identity and feeling like you are participating. It has nothing to do with cooperation, the past, or the future. It's living in the present. I think the same is true for most people who write code for money. They have no idea where their cultures came from. Adam Kay, in interview with Dr. Dobbs Journal, 2012. Table of Contents. Preface. Part 1. Foundation of Data Systems. Reliable, scalable, and maintainable applications. Thinking about data system. Reliability. Hardware faults. Software errors. Human errors. How important is reliability? Scalability. Describing load. Describing performance. Approaches for coping with load. Maintainability. Operability, making life easy for operations. Simplicity, managing complexity. Evolvability, making change easy. Summary. Chapter 2. Data models and query languages. Relational model versus document models. The birth of NoSQL, the object relational mismatch. Many to one and many to many relationships. Are documents databases repeating history? Relational versus document databases today. Query language for data. Declarative query on the web. MapReduce querying. Graph-like data models. Property graph. Decipher query language. Graph query in SQL. Triple store and SparkQL. The foundation data log. Summary. Chapter number 3. Storage and retrieval. Data structures that power your database. Hash indexes. SS tables and LSM trees. B trees. Comparing B trees and LSM trees. Other indexing structures. Transaction processing or analytics. Data warehousing. Stars and snowflakes. Schemas for analytics. Column-oriented storage. Column compression. Sort ordering column storage. Writing to column-oriented storage. Aggregation. Data cubes and materialized view. Summary. Encoding and evolution. Chapter 4. Formats for encoding data. Language-specific formats. JSON, XML, and binary variants. Thrift and protocol buffer. ACRO. The merits of schemas. Model of data flows. Data flow through databases. Data flow through services. REST and RPC. Message passing data flow. Summary. Part 2. Distributed data. Chapter number 5. Replication. Leaders and followers. Synchronous versus asynchronous replication. Setting up new followers. Handling node outage. Implementation of replication logs. Problem with replication lag. Reading your own writes. Monolithic reads, consistent prefix reads. Solution for replication lags. Multi-leader replications. Use case for multi-leader replication. Handling write conflicts. multi-leader replication topologies, leaderless replications, writing to the database when a node is down, limitation of quorum consistency, sloppy quorums, and hidden handoff, detecting concurrent writes. Summary. Chapter number 3, partitioning. Partitioning and replication, partitioning of key value data, partitioning by key range, partitioning by hash of key, skewed workloads and relief hotspots, partitioning and secondary indexes, partitioning secondary indexes by document, partitioning secondary indexes by term, rebalancing partitions, strategies for rebalancing, operation, automatic or manual rebalancing, request routing, parallel query execution. Summary. Chapter number 7, transactions. The slippery concept of transactions, the meaning of ACID, single object and multi-object operations, weak isolation levels, read committed, snapshot isolation and repeatable reads, preventing loss updates, write skew and phantoms, serializability, actor serial execution, two-phase locking, 2PL, serializable snapshot isolation, SSI. Summary. Chapter number 8, the trouble with distributed systems, fault and partial failures, cloud computing and supercomputing, unreliable networks, networks faulty practice, detecting faults, timeout and unbounded delays, synchronous versus asynchronous networks, unreliable clocks, monotonic versus time of day clocks, clock synchronization and accuracy, relying on synchronized clocks, process pause, knowledge, truth, and lies. The truth is defined by the majority, Byzantine faults, system model, and reality. Summary. Chapter number 9, consistency and consensus. Consistency guarantees linearizability. What makes a system linearizable? Relying on linearizability, implementing linearizable systems, the cost of linearizability, ordering guarantees, ordering and causality, sequencing, number, ordering. Total order broadcast, distributed transactions and consensus, atomic commits and two phases commits, 2PC. Distributed transactions in practice, fault tolerant consensus, membership, and coordinated services. Summary. Part number 3, derived data. Chapter number 10, batch processing. Batch processing with Unix tool, simple log analysis, the Unix philosophy, MapReduce and distributed file system, MapReduce job execution, reduce, side, join, and grouping, map side joins, the output of batch workflows, comparing Hadoop with two distributed database, beyond MapReduce, materialization of intermediate state, graph, and iterative process, high-level APIs and languages. Summary. Chapter number 11, stream processing, transmitting event streams, messaging system, partitioned logs, database and streams, keeping system in sync, change data capture, event sourcing, state, streams, and immutability, processing streams, use of stream processing, reason about time, streams joined, fault tolerant. Summary. The future of data system, data integration, combining specialized tool. Chapter number 12, the future of data system, data integration, combining specialized tool by deriving data, batch and stream processing, unbundling databases, composing data storage technologies, designing application around data flows, observing the diverse state, aiming for correctness, the end-to-end argument for databases, enforcing constraints, timeliness and integrity, truth, both verify, doing the right thing, predictive analytics, privacy, and tracking. Summary, glossary, and index.